Architecture artifacts are not paperwork. They are how architects make choices visible. In this topic, you'll practice reading scenarios, selecting the right catalogs, matrices and diagrams, and justifying decisions through stakeholder value, trade-offs, and governance. We've built the foundation: why enterprise architecture matters, how TOGAF structures the work, and how ADM phases produce architecture outputs. Now we shift from understanding the process to practicing judgment, choosing the right artifacts, using them appropriately, and defending decisions in realistic enterprise AI scenarios before moving into Azure architecture. Good artifacts make complex decisions understandable, testable, and governable. When you choose the right one, stakeholders align faster and decisions become easier to trace. When you choose poorly, you create ambiguity, duplicated effort, and choices that no one can confidently explain later. Think of TOGAF artifacts as three lenses. Catalogs answer, what do we have? They create controlled lists of actors, capabilities, applications, data, or technologies. Matrices answer, how are these things related? They show mappings, ownership, coverage, gaps, and dependencies. Diagrams answer, how does it work or change? They make flows, structures, interactions, and life cycles easier to understand. The skill is not filling every template. It is choosing the artifact that best answers the stakeholder's question, then keeping it clear enough to support a decision. Stakeholder maps show whose concerns must shape the architecture. Executives may focus on strategic value, security teams on risk, data scientists on usability, and customers or regulators on trust and compliance. A capability map then translates those concerns into what the enterprise must be able to do, independent of today's org chart or tools. For an AI platform, that may include secure deployment, data governance, model monitoring, and responsible AI oversight. Together, these maps turn scattered viewpoints into clear priorities for investment and decision-making. Application communication diagrams make runtime relationships explicit. Instead of listing applications in isolation, they show who talks to whom, through which interface, and for what purpose. In an AI platform, that might include portals calling APIs, APIs invoking model services, data platforms feeding information, identity services issuing tokens, and monitoring tools collecting logs and alerts. Their value is architectural insight, spotting tight coupling, duplicated integrations, insecure exposure, and operational dependencies before they become migration risks. They are especially useful in Phase C and when planning phase delivery. A data lifecycle diagram turns governance into a process you can reason about. Data is created or collected, then stored, secured, processed, used, shared, and eventually archived or deleted. At each step, architects ask what controls are needed: encryption, classification, consent, retention, quality checks, and lineage. For AI systems, this view is especially important because training data, inference inputs, model outputs, monitoring signals, and feedback all depend on governed flows. It helps teams spot risk early, particularly with sensitive or regulated data. Technology architecture diagrams turn the target design into an operational blueprint. They show where workloads run, which platforms host them, how services connect, and where security boundaries apply. In Phase D, this helps validate that the architecture can actually be deployed and operated. For an Azure AI solution, the diagram makes choices visible: virtual networks, private endpoints, identity, key vault, Azure OpenAI, data services, monitoring, and runtime compute. The value is not the icons. It is the conversation they enable about resilience, scalability, ownership, and risk before implementation begins. Gap analysis is where the architecture vision becomes actionable. We compare the current baseline with the target architecture and ask, what is missing, what must change, and what should no longer exist? The matrix makes those decisions explicit across each architecture area. It can reveal missing capabilities, duplicate systems, obsolete technologies, or new building blocks required for the future state. Just as importantly, it records impact and recommended action, so priorities are not based on opinion alone. The result feeds directly into roadmaps, work packages, migration plans, and stakeholder justification. Let the question choose the artifact. If the concern is political, such as who approves, who influences, or who needs communication, use a stakeholder map. If the concern is strategic, such as which capability is missing or where investment should go, use a capability map or gap matrix. If the concern is execution risk, such as system interaction, data movement, deployment, or technology dependency, use application, data, and technology diagrams. Good architecture work is not producing more pictures. It is selecting the clearest evidence for the decision. An architecture decision record turns a choice into organizational memory. It starts with the context, the requirement, constraint, or problem forcing a decision. Then it records the options considered, the decision made, and the rationale for choosing it. It also captures consequences, risks, status, owner, and date. That structure creates traceability from business drivers to architectural outcomes and prevents teams from reopening the same debate months later. For high-impact areas like security, cost, compliance, performance, vendors, or platform strategy, ADRs give governance reviewers evidence, not opinions. A strong architecture decision is more than we chose option B. It shows the path to that choice. Compare realistic options against shared criteria: security, cost, scalability, compliance, complexity, and delivery time. Then name the trade-offs clearly. What do we gain and what do we give up? Risks need the same discipline: likelihood, impact, mitigation, and an owner. Finally, the rationale should connect the decision back to principles, stakeholder concerns, business goals, and constraints. That makes the decision reviewable, defensible, and useful later when conditions change. Scenario questions test judgment, not recall. Start by reading for context. Who is concerned, what constraint exists, and what information is missing. Then map the situation to the ADM phase and its objective. Next, identify the real concern, such as risk, stakeholder agreement, a requirements change, or a gap between current and target states. After that, choose the most appropriate artifact or action. Finally, validate the answer against architecture principles and governance. The best option is usually the one that supports the next responsible decision. In practice, architecture work connects competing concerns into a defensible path forward. For a secure AI platform, begin by mapping who cares about speed, security, delivery, and data. Then choose artifacts that answer those concerns: capabilities, data lifecycle, platform design, and migration gaps. The ADR captures a key choice, such as private access for AI services, along with its trade-offs. Governance then checks that the decision fits principles, security requirements, the target architecture, and the roadmap. The practical lesson is to choose artifacts with intent. Use catalogs to list, matrices to relate, and diagrams to make complexity visible. Start with stakeholder concerns and the question you need to answer. Then capture decisions, trade-offs, risks, and rationale in ADRs. Next, we apply this judgment to Azure Enterprise AI architecture: landing zones, identity, access, and secrets.